Thanks for sticking around. I really thought the crowd would maybe be a little more dwindled given the time of day and that I'm holding you guys from Beer 30, but thanks for being here. My name is Jill Randall. I'm the Big Game Migration Coordinator for the Wyoming Game and Fish Department, and I am excited to talk to you about a case study with our Carter Mountain pronghorn herd. So our department has a rich history of using GPS collar data to really help inform conservation practices on the ground. We put a lot of stock, a lot of weight in our GPS collar studies that we've done throughout the state. We use them for anything from planning conservation easements, fence modifications, cheatgrass treatments, all sorts of different conservation actions on the ground to really help us prioritize where to put those limited funds that we have. We also use that GPS collar data to help inform where we designate migration corridors. This is a formal process that's established through our Wyoming Migration Corridor Protection Executive Order. Like the other Western states, we were fortunate enough to acquire some additional funding for GPS collar work through Secretarial Order 3362. During 2018 and 2019, we were able to put collars out in 6 additional herds that we did not have either any data or adequate data. 3 of those are pronghorn herds and 3 of those were mule deer herds. You'll notice the northwest green polygon, that is the Carter Mountain pronghorn herd that I'm going to be focusing on for the rest of this talk. So this Carter Mountain pronghorn herd has approximately 6,300 individuals. It's a mix of public and private land on the east side of the Greater Yellowstone ecosystem. They summer in the west portion of the herd in the Absaroka Mountains, and then in the winter they move down to the Bighorn River in their lower elevation winter ranges. We had 128 pronghorn collared from 2019 to 2022 that we used for this study. The objectives were pretty broad, pretty general, really just to understand seasonal use and migration habitat. We didn't have any data in this particular herd prior to this collaring effort. So we were able to partner with West to collect a great amount of data, learning an awful lot of just natural history components of this herd. They migrate between 40 and 60 miles. Phenomenally, they are very unique in that some of them will travel 6,000 vertical feet in elevation between their winter and summer range. So that is meaning that they're summering, the portion of the migratory herd, some of them are summering over 10,000 feet in what we consider an alpine habitat. Very unusual for pronghorn to be doing that. And they are also coexisting with the full suite of natural predators, including grizzly bears, mountain lions, and wolves. So we've got tough pronghorn in Wyoming. But it's kind of interesting, like many of our other pronghorn herds, we realized that their migrations are a lot less predictable than mule deer. That means both spatially as well as temporally. This particular group of animals that we did have over 800,000 GPS points on was determined to be about 50% migratory. 25% are residents, and then another 25% are nomadic. Those residents and nomadic individuals really are on the east side of the herd, down around what we consider winter year-long habitat. So we did our standard modeling process to determine corridors, and that is a line buffer method using 300-meter buffers. We determined high, medium, and low use portions of this corridor by looking at the different percentages of individuals that are using those areas of the corridor. We also determined stopover areas based on a Brownian bridge movement model analysis. Again, that's the standard that we're using across all species in Wyoming to determine stopover sites. And it's getting at the top 10% of utilization distribution values for those individual routes. Not a surprise, they are also highly overlapping with our high use areas. In this project, we also determined winter habitat, patrician habitat, and some of the year-round habitat that I'm not going to go into for today's talk. It's long been understood that pronghorn require wide open landscapes to move between seasonal habitats, and those connected habitats can have a lot of different barriers and obstacles within them. Some of those being roadways, railways, or railroads, and fences. We do have an awful lot of woven wire fence, sheep fence, if you would, that was on our landscape historically in Wyoming. And as our sheep producers, a number of them have converted over to cattle. We have also been working towards converting some of those fences to provide more access to pronghorn. In this particular study, we didn't focus on fences as much, but more so roadways. And we were really looking at where those animals are crossing 4 major highways within the project area. So I'm going to have a series of maps that I want to show you. Again, these were all generated through our partnership with West and Dr. Hall Sawyer. And we also received an interactive HTML, which is a really awesome resource for our managers that can go in and kind of manipulate particular pieces of ground that they're interested in. If they really want to zoom in on a project area opposed to the whole herd, we can go in and kind of manipulate the different data sets in there. So definitely encourage you to look into using those. They're a pretty awesome resource for managers. The first thing I want to present on here is the total number of crossings by milepost. So I mentioned we've got all these individuals, we've got all these data points, which of course were connected with lines. And every time those lines cross the road, we identified those hot spots, again, using high, medium, and low kind of heat maps. That's what you'll see demonstrated with the different colors here. So the high being red, medium orange, low green, and those blue areas had 0 crossings in them. So these are showing us some of those important crossing points by milepost. Because we had a few individuals that were hanging out near the road, our data was getting a little bit skewed by a couple individuals that were crossing repeatedly. So we also looked at the data a little bit different, looking at the number of individuals that crossed by milepost opposed to the individual crossings. It was just another way for us to kind of sort out the data because we didn't want to be biasing it for some of our questions by those individuals that were hanging out right along the road. The next component was something that I was really excited about. I think, not to say it hasn't been done anywhere else, but this is one of the more intensive efforts in Wyoming that we looked at using our GPS collar data to determine where on the road movements were either stalled or blocked. So by looking at locations within 300 meters of the road, we were able to determine those areas where a collared individual was coming to the road and staying there in that buffered area opposed to crossing right across. Those areas were done independently on each side of the road because we know there are certain variables like fence design, topography, vegetation that could be allowing movement much more readily from one side of the road opposed to the other. So you'll see on the map, there's 2 different colors that are opposed to each other to each of those mile markers on the map. Likewise, we also decided to look at individuals opposed to the crossing events, or I'm sorry, the events of approaching the road. We also wanted to avoid some of those biases by those individuals that they're hanging out roadside. So we just choose to look at the data in a couple different ways. Again, getting that high, medium, and low categories on both of the different sides of the road. So when we were able to look at all of that data collectively, we really wanted to bring in that additional layer of looking at our wildlife vehicle collision data that we collect in partnership with the Wyoming Department of Transportation. In Wyoming, more than 7,600 ungulates are killed per year that are documented. I know we've all probably heard a couple times today. We know that number is grossly underestimating reality. And the cost associated with those documented mortalities is around $200 million annually. So in this project area, the wildlife vehicle collisions are increasing about 6% per year. Unfortunately, our pronghorn population is not. So this means as time goes on, a larger and larger percent of the mortality in the herd is actually attributed to wildlife vehicle collisions annually. In this particular project area, looking at all of our wildlife vehicle collision data, 63% is from mule deer. That's common in Wyoming for mule deer to be the highest percentage. 16% was from pronghorn, 15% white-tailed deer, and 6% from elk. So we certainly have multiple species interacting here in this landscape and all playing a role in the wildlife vehicle collision data. The thing that caught our attention is that the percent of pronghorn wildlife vehicle collisions was more than about twice our state average. So it caught our attention when we were looking specifically at conservation of this particular pronghorn herd. Those traffic volumes is another component that we looked at. You'll see on the graph here on the left, the traffic volume on this particular stretch of road has greatly increased from 1970 through recent times. This area is right outside of Yellowstone National Park and Grand Teton National Park, receives an awful lot of vehicle traffic by tourists, and that traffic and volume level obviously has gone up dramatically. We are pretty concerned about this particular area and what this traffic volume increase means for those gaps between vehicles in our roadway system. So in areas where you have less than 60 seconds gap between vehicles, we see that there's a reluctance for animals to even attempt to cross the road. So we're approaching that threshold where we might be getting a barrier and animals might be they're stopping to attempt those crossings, which is certainly not good when we have a highly migratory herd that we looked at here earlier. So as we're approaching that threshold, it kind of created a sense of urgency for the agency to try to find a solution. So in Wyoming, we have been fortunate enough to go through a prioritization process that was started after 2017 Wildlife Roadway Summit. And in this process, we really looked at a lot of different inputs as far as wildlife vehicle collisions, the feasibility of solutions for different priority areas. Unfortunately, we all know there's some areas that have a lot of collisions, but there really just isn't an immediately feasible solution, even if money is not in play. But the fact that we were able to develop a top 10 list is something that we've kind of worked on. And that top 10 list is not the smaller projects that are happening throughout the state. These are the big projects that are requiring, for example, federal funding to come in, projects with overpasses, underpasses, et cetera. We can only take on so many of those based on the funding capacity component. So we've prioritized. On that top 10 list, fortunately, a number of them have been already implemented. We have another one that's fully funded, ready to be implemented. And then we have two others that are planned, that we have a project ready to go, Du Bois being one of them. And we're actively trying to solicit federal funding for those. So we have this next top three, if you would. This project area is in the top three for developing the solutions on the ground. We're looking at three different projects that are spatially spread out across the state, have very different kind of strategies and approaches. But right now, what we're doing is working with our local game and fish people and our local Department of Transportation folks that know that area, looking at the data that we have like this to feed into developing those solutions. In this particular area, we know that most of the pronghorn are crossing in 2 locations, and so overpasses will be proposed in probably both of those. Overpasses, whether we're able to do 1 or 2, will depend on our budget availability, but we now know where we need to place them based on having this data. We'll also, of course, have high fences throughout the project area and a number of underpasses to accommodate all the other wildlife species that are in play. That is what I have. So thank you very much for being here at the end of the day, and I'm happy to take any questions. Yes.
The herd year is just less of the higher mortality rate, so that's times the state average. Does it increase availability or?
So the question was, did we determine why the higher relative abundance of wildlife vehicle collisions here compared to the statewide average? And, you know, a lot of it is the absolute necessity for these animals to cross the highway. If they're a migratory individual, you can't get from that summer range to winter range without crossing those highways. There's no roundabout path. Even though pronghorn do tend to have a fair bit of flexibility, there just isn't a way to get from point A to B without crossing highways for this particular herd. That's likely the reason why. In some other places, you know, they might have options to bubble around or avoid, you know, a barrier that they don't, or a partial barrier. But here they just don't. Yes.
That 2-mile segment of Wyoming 120, what's the present right-of-way fencing strategy along that 2 miles?
The question is, what's the current fencing along that stretch of highway? And I honestly don't know for certain. We have a big mix of fences. A lot of our highways, because of safety for motorists, are woven wire fence. I don't know 100% for certain if we have that there or if there is a mix of some wired range fence that goes through there. I suspect it's not all woven wire, otherwise we would be having bigger complications with crossing those highways, but we know these critters are certainly pretty creative about finding their location. They can scoot through. I know one of the things that we've talked about in the interim before we get federal funding to do the full-blown solution in several of our project areas is trying to go through and do some intermediate fence modifications. It's just hard to justify the expense of going through and doing something if you're hoping within the next 5 years you're going to put an 8-foot tall wildlife proof fence in there. You hate to kind of invest money 2 times in the same stretch of road.
Did I misinterpret your map then? It looked like they were already getting across the road.
They are getting across the road, absolutely. It's just a question of, are they finding those little gaps to squeak in and around, or are they freely able to cross because it's a 3 or 4 wire fence? And I apologize, I don't know that particular spot, what we have for the right-of-way fence there. Yeah, Andy.
Hey, Joe, this question was similar, but I was just going to ask, do you think you have the data to ground truth the fences? I mean, especially in places you have different permeability on each side of the same highway, and those are likely the same animals going back and forth. Seems like if you compare fence structure on both sides, you could use your data to help some of us that have struggled with this in places we don't have to call our animals. You know, essentially flip it around, allow us to evaluate permeability based on fences without calling them.
Yeah, so the question is there a way for us to look at those existing fences on the ground and help determine, you know, what those variables are that are either slowing down or preventing movement to try to help inform places where we don't have color data? We're always looking to try to expand our knowledge of information because nobody can color everywhere that they want to. That's just reality. Yes, we absolutely do have the information to be able to go in and do that. I know in some places they felt like topography and vegetation was also at play, not just fence style. So sight lines and, you know, pronghorn in particular are very sensitive to those sight line differences. And so there's probably multiple factors at play, but we do have the information now to go in and make some of those site-specific evaluations. It'd be great if it was black and white and simple, but in this world, we all know it rarely is, unfortunately. Yes.
Probably close to the end. On the fence type, I'm interested, you indicated an 8-foot fence. Is this an area that is a high snow flow zone? Have you evaluated the effectiveness of the fence to stay up to the environment conditions?
So the question is the environment and snow loading something that will be feasible to have an 8-foot tall fence? Yes, this is in big snow country, but I can say firsthand, we have some places that are bigger snow country in Western Wyoming that we have had 8-foot tall fence for many years. Highly effective regardless of snow loading. We haven't seen a problem. I'm not going to say that it might contribute to more maintenance over time, but we haven't found any problems with big winter snow and holding up to those conditions.
We can take one more question?
Yeah.
This is a 300-meter buffer at these times, and I'm just wondering why.
So the question is why 300 meters for the buffer? And the line buffer method that we're using for monitoring our corridors is determined based on some research that Dr. Jared Merkel led that was looking at various fix rates on different individuals and trying to accommodate the variance that occurs. There's a great paper and publication I would love to get to you. I come find me afterwards, I can do that. And it really honed in on 300 meters being kind of the sweet spot. So we definitely have used that number consistently, again, across species, because it really, it set up that being the number with the research that Dr. Merkel led.
Thank you, Carol.
Yeah.